Good evening. As discussed in last class, today I'll explain you what is DevOps. It's just an introduction class for DevOps. Okay, it's not completely like just starting DevOps. This is just introduction. Like from tomorrow onwards, so we'll start Linux classes anyways. Then after that, from next week AWS. After 1 month DevOps. But this is just few people asked. That's the reason I'm telling. Are you guys available? Who asked what is DevOps session? What is DevOps? Are you available? Okay, I'm giving unmute option.
Yes, sir.
Okay. Right. So, organization needs, see, first of all, to bring any organization into top position, they need to follow few things to achieve that. Like whatever the application they are working, that should be delivered fast. Not only delivering fast, but at the same time, they should give with a high quality. That application, that output should be with high quality output, with less spending, means with the minimum budget. How they are giving a high quality output to the customers, and with faster delivery, means as soon as possible they have to deliver to the customers with high quality, with reduced outages means like with minimum downtime of the application. If you follow all these things, if any organization is following all these things, then they can be in top position. So what we need to do to follow these things, how can we achieve all these things? Let's discuss now. Mm, yes. So let's say uh, so he is railway minister. He is planning to bring one application to all the passengers all over India to book the train tickets from one place to another place. Like assume there is no IRCTC application as of now. So he is planning to bring an IRCTC kind of application, but he cannot develop that application because he's a politician, not a software developer, right? So what he'll do, he's going to one IT company and talking to the IT manager, like I have a requirement, like all the passengers across India, they should be book the tickets. They should not go to railway station to book the tickets, just to stand in the queue, all things. No, just by sitting in the home from computers, laptops, mobiles, also they should be able to book the tickets. So for that, can you develop an application for that? Means this IT manager, like, yeah, okay, we can do that. Like they're saying, like we need 1 year time with some 1 crore budget, 1 crore budget, 1 year time. If you are okay, then we'll start this. So now railway minister is saying yes, okay, that's not an issue. We'll give 1 year time, 1 crore budget also. Like we are okay with that. So then only they'll start working on that thing. So here this railway minister is giving a task, right? So we call that task as project. Whoever is giving the task, we call him as client because he is giving the requirement. His client is giving a project, and wherever this client is sitting, we call it as on-site. On-site means not America, Australia, London. On-site means client location. And where the team is working, we call it as offshore. Okay. So this is a DevOps introduction class. Then the first stage, starting with once the agreement is done, once everything is okay, first stage is what? Designing stage. So this IT team, they'll start designing the application. what kind of application they need, which programming language they have to use for front end, which database they have to use for back end, how many pages are needed, like what kind of drop down button, text box, radio buttons, like which colors should be used, like what tables, everything they will design. Once designing phase is completed, then next comes coding. Developers start working on the code. They'll write coding to develop that application. Once coding part is done by all the developers, like there might be 4 developers, 5 developers. Once all the developers are ready, they have done coding, they have uh, checked if that code is working properly in their laptop, then comes build. Build team will perform build, building the application. Building means what? Building means compiling the source code. Means it compiles source code and creates machine readable format, executable. Computers, laptops cannot understand source code. Source code means whatever the programs as a human being we are writing, that can be C language, C++, C sharp, Java, Python, whatever. Machines cannot understand. Machines will understand only binary language. So here build means it will compile the code and it will create some executable file. So once the compilation is done, then comes next stage, that is testing. So for here, testing team will perform all the test cases, like whether the application is working properly or not, whether the login page is working properly, user registration page, welcome page, whether invalid password, is it throwing any errors, if password is wrong, if everything is correct, if it is taking to the application. Like different types of test cases, some hundreds of test cases they will write, and they'll perform all positive test cases, negative test cases. If everything is valid, then testing team will give thumbs up. Yes, our application is working properly. We are good. We can ready to deploy the application. So finally, once testing team say okay, then comes QA team. QA team will perform the code quality. Means developers are writing the code. It is giving some output, but whether the quality of the code is also good or not, we need to check that. So there are two persons. I'm asking to print hello world statement. This person written program in Java to print hello world in 2 lines. The other person also written the program in Java to print hello world. He took some 10 lines. He declaring some int a is equals to b, a is equals to 10, b is equals to 20, some unnecessary variables he's declaring. He's passing some values, he's importing some libraries. But ultimately he's also doing printf hello world. Same output hello world, same output hello world. But quality wise, which code is good means this person's code is good because whatever is needed he kept that statements, and this code is taking very less time for execution, like hardly 1 millisecond, but it is taking like 5 milliseconds. So here the quality wise this code is good. So who can test this means QA team. In QA team will quality assurance, this team will check the code quality. So all these teams are involved for development, for developing the application. These all teams comes under development. So these all the teams developed an application. Like for example, if it is an IRCTC, and then IRCTC.var file. So this is the application they have developed. It is like an executable file. Executable file means, let's say I want to download Chrome. I want to use Chrome software. So what I'll do? Download Chrome. I'll type. Now, if I click on this download Chrome button, will it download all the programs which are written by the developers to develop this Chrome software, or will it download one executable file? Hmm? Any
It
idea?
will, yeah, it will download executable file only.
Executable file only. That means whatever the developers has written the code, that final output they are giving for us, but they are not giving the source code, the test cases, not right. So here
Yes.
also, this executable file, whatever we have developed, this executable file we need to deploy. Who is going to deploy? That means Here comes operations team. So here in operations team, like our operations team, or we can call it admin team, they will perform deployment. Deployment means they'll deploy this application in the servers, in physical servers or cloud servers, whatever the servers client in client machine they'll deploy. After deploying the application, then monitor. Monitoring team will monitor the metrics like CPU utilization, storage, application, whether it is working properly or whether it is down, they'll monitor. And there is also a maintenance team. Two types. Either the client can take care of maintenance, otherwise, whoever the IT team developed the application, they can continue for maintaining this project, even though finally application is hand over. So finally deployment is done. Everyone who is tapping www.irctc.com, people can able to access IRCTC application. They're booking the tickets. Project is completed. But maintenance is like, even though the project is completed, in future if suddenly IRCTC website is down, we if we are typing www.irctc.com, the application is not visible, site issues, or sometimes login page is not working. Like, who can take care of this? Whether this IT railway minister means what he'll know, he will be like removed from that post. He may be not the minister after 2 years. But who is responsible? Two things: either who is taking care of maintenance, the client, or this person. This person means here the IT team. If IT team is taking care of maintenance, they has to resolve the issues on priority. Otherwise, if they don't want to take care of maintenance even after handing over the project, from client side only, there will be 3 4 software employees. Like the railway minister will hire 3 4 software employees. So those software employees only will take care of maintaining the application, so that there will not be any um, further relation between this IT team who is developed the application and the future issues if it is coming. So the client will take care of that if they are taking care of maintenance. So to complete this project, these many stages are involved here, like the development, designing, then we have the code, build, test, QA, like deployment, monitoring, maintenance. So all these stages we have to complete to develop an application. So different types of stages we cross. Like, this is like a life cycle. Again, if another project is coming, like another, we need to start from designing only. Directly, we cannot take care of maintenance. Anyone for any project, you might be work on any project, banking project, supermarket project, whatever project you work. But you need to start from where? From designing the application only. Directly, you will not deploy the application without developing how you will deploy. So first you need to design, then code, build, test, QA, deployment. Like, this is the cycle, life cycle. So whatever this life cycle we are following, it is called as software development life cycle. SDLC, software development life cycle. In SDLC, this approach, whatever we are following here, this approach we call as waterfall method. This method we call as waterfall method. In waterfall method, we have few drawbacks. See, nowadays nobody is using, in any project, waterfall method is not using, because we have few drawbacks. What are they? First, let's say client has given the requirement, developer started working on the code. After 3 months, this railway minister came to that software company and is asking, while booking the tickets, as per our discussion, they have to pay the amount using net banking. But recently, phone pay, Google Pay, these methods also came, right? So can you include these UPI method, QR code method? Like, he's asking. But this IT team is not considering their request, because in waterfall method, once the requirement is received, further no more requirements will be taken. This is a huge drawback. New requirements are not received. They will not take any new requirements. And See, developers has written the code. This is deployed by the operations team. But see, operations team guys, they deployed in Windows machines and Linux machine. In Windows, it is working properly, but in Linux, it is not working. So this operations team people blaming developers. You guys did not written the code well. It is not working in Linux servers. But what developers are saying, we have tested in our machines before deploying. It worked fine in Windows as well as Linux. Maybe that is deployment issue, maybe infrastructure issue. You maybe did not configure the infra properly. Like there is a miscommunication. In waterfall method, there will be miscommunication. Issues can also happen. And there is no faster delivery, delaying in delivering the applications. Until designing is done, developers cannot write the code. Until coding part is done, no build. Until build is done, no test. Until there's no QA, no deployment. In this way also, the delivering of the application is becoming slow. So what we need to do means we have an advanced methodology to address these issues, whatever we are facing in waterfall method. That is agile methodology. Agile methodology is advanced thing of waterfall methodology. So what new things are there in agile means in agile methodology customers will give requirements in the form of sprint 1, sprint 2, sprint 3, like they'll come with sprints. In sprint 1, like sprint 1 they came with some requirements. So they want to develop one IRCTC application. They have given some login page, registration page, welcome page, like all these things to book the application. Okay, fine. First, designing the application is done. So sprint 3 will be for 3 months. Within 3 months, this ID team has to work on the sprint 1. After 3 months, again, client will come with one more sprint. After again 3 months, again he will come with one more sprint. So that's why in these 3 months only they have to complete this sprint with all the new requirements. Design, then writing the code, then building the application, testing. So all they will do all these things. Sprint 1 is completed. They took 3 months to complete sprint 1. Again, in sprint 2, client is coming with some new ideas. Like he's asking for implement QR code, UPI payments, to add some wallets, IRCTC wallets. So this kind of some new requirements you can. Yes, again, we need to again design the things. Without designing, you cannot write the code directly. Again, designing means what? Where this QR code option should be kept. See, if you see Amazon, Flipkart, or Book My Show, phone page, some different applications. Not every app will have same options to pay the things. In Amazon, there will be some different options will be shown. In Book My Show, some different will be there. In Hotstar, different, Prime different. So that is designing, like how you design, how you write the code. So first design, then you write the code, then build the code, test if all is working fine. Again, after here 3 months they worked, here 3 months they worked. Again, in this before seventh month, again they came with some more new requirements. Here they're asking for some live tracking location, some other requirements like face detection to open to unlock this IRCTC app, face detection and fingerprint. These requirements they're coming with. Again, they'll start working on the things, design, code, build, test. And finally, in the end of the third sprint only, they will deploy the application, this entire application. So here in this agile methodology, first issue we are addressing. What is the first issue? Sprints. In waterfall methodology, they are not taking new sprints, but here new sprints are taking. Okay. And miscommunications are happening in waterfall method, but here no miscommunications because here status calls are going on every day. We can call status call stand-up call, like scrum meetings also used to say. That means all the team members, all the teammates will join the call, like developers, testing team, building team, build team. Everyone who is working the project, they will join the call. They has to tell their status, like who is working on which task. Like I'll tell you, yesterday I worked on this. So I have tested few test cases. It worked fine. Today I will work on this task. And the other developer will say, like today I'll work on this code changes, so that everyone in the team will get to know what's happening right now, like where we are, like how the things are going on, how we are progressing the things, like everything will be aware of, so that there is nothing to blame on each other. If there is an issue, okay, we'll get to know, then we'll sit together and we can sort out the things. So here there is no miscommunications because of this status calls. And but still we are not delivering the application faster. No delivery still, like even though the sprint one is done, sprint two is done, but finally only in the last sprint only we are deploying the application. So to address these, what we are doing, we have another methodology. What is that? DevOps methodology. So DevOps is a methodology advanced to agile. It is not a programming language, it is not a technology. Uh, it is a method, it's a process, or it is a culture. The term DevOps came from development, dev, operations, ops. So DevOps is a team, like, or DevOps. So let's say I'm a DevOps person. So a DevOps person should have knowledge on build side, code side, lightly means you no need to develop the code, like basic understanding things, build side, code side, like QA side, or deployment side, monitoring side, like, because DevOps is a combination of development and operations. Here you should be having some idea, and here also you should be having some idea. These DevOps teams are replacing build team. Like earlier, we used to have separate build team, separate QA team, separate deployment team, separate monitoring team. But now the management is removing all these teams. Like if there are one, 2 persons in build, 2 persons QA, two, like 8 people are there. For each person, the management is paying 50,000 salary, let's say 50-50, 1 lakh, 1 lakh, like 4 lakhs they are paying salary for 8 people. Now what management is doing, they are removing all the 8 members and they are hiring only 2 DevOps engineers. Now for each person they are paying, like let's say 1 lakh. 1 lakh means, like, per month they are paying 2 lakhs to only 2 DevOps engineers. Client also saving here 2 lakhs, and the employees also getting more amount, like more salaries, double salaries. Why? Because they are taking care of build side, they are taking care of QA side, like they are involving in all the things. So they are like all rounders. So DevOps team is replaced by sorry, DevOps team is replacing build team, QA team, deployment team, monitoring team, like all these teams. So they should be having knowledge on development side as well as operation side. Here in DevOps, we integrate different types of tools. Here also we take requirements in the form of sprints only, like sprint 1, sprint 2, sprint 3. But here the difference is, as soon as the designing is completed, then we go for code, then we go for build, then we go for test. And here we, after build, code, build, test, and we deploy the application at the third month only. Deployment is done. Our IRCTC application will be coming into the market, launched in the third month itself. And in sprint 2, this is like upgrading the application. In sprint 3, this is like one more version of the application, IRCTC with new features. But application is launched. In there it launched at 12th month, but here in third month only it is launching. The reason here we use tools, like at this stage we are using source code management tool like GitHub. At this stage we use build tools like Maven or Ant. Here Selenium, JUnit, these kind of testing tools, QA tools like Checkstyle. Here deployment tools like Docker, Kubernetes, and monitoring like CloudWatch or Datadog or Nagios, different types of tools, and CI/CD tools like Jenkins, or we have Circle CI, uh, one more Bitbucket, different types of CI. So all these tools are integrated with Jenkins, and Jenkins is it's like a captain of the ship. It's kind of, it's very important because all the tools are integrated with Jenkins. everything is like automated. Here we install that as a DevOps engineer. He is responsible for installing all these things, not testing Selenium. This is separate testing team will take care of that. But like GitHub, build tool, deployment tools, like monitoring tools, like who will install DevOps team, and who integrates all these things with Jenkins, DevOps team, and who will automate all these tasks, DevOps team will automate. Automating means like if a developer has written the code in his laptop, and finally once everything is worked, like the syntax is good, if the unit test is properly, and all the developers from the laptops, they'll push the code to one source code management tool like GitHub. Once the code is pushed to GitHub, then this Jenkins will pull that code, send to build. Then once the build is done, it creates that executable file. Jenkins will take that code and send to test. Testing team will perform all the test cases. Once testing is also completed with all the valid cases, then Jenkins will pull the code, send for QA. QA tool like checks to it will perform all the code quality checks. Then Jenkins tool will deploy the application on tools like Docker or Kubernetes. It's like automation. So using DevOps tools, we are automating the things to finish the things as soon as possible. And with these DevOps, we are achieving faster delivery of application at the same time with high quality. How we are achieving high quality? Because we are working with tools. If manually we do the things, there may be issues, errors, but we are integrating everything with tools, right? So we are achieving with high quality of application with less spending. How means DevOps engineers are replacing all other teams, so we are lesser spending with reduced outages. Reduced outages means as soon as the application was deployed, the application will be available, and if some issue is occurring, and immediately the developers will fix the issue by deploying the code again. So here you will be getting minimum outages, minimum downtime of the application. So using DevOps, we can achieve all these things. If you observe the differences here, waterfall versus agile versus DevOps. In waterfall, like we need to design the application, then only you need to write the coding, then test the application, and finally deployment. In agile methodology, like design, code, test. Again, sprint 2, design, code, test. Sprint 3, design, code, test. Like design, code, test. Finally, deployment. But in DevOps, you design the application, you write the coding, you test the application, and you do here deployment. Again, next sprint, design, code, test, deployment, 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 deployment. As soon as you're coming with a new sprint, deployment will be happen. So we are achieving this using CI and CD tools like continuous integration and continuous deployment tools like Jenkins. Let's see the definition for DevOps. Let's see. DevOps is a set of practices, tools, and cultural philosophies that integrate software development. Means it is a combination of development side and IT operations side. The term is a combination of words, development and operations. So DevOps is a combination of both development and operation. So finally, why it is combining the things, what it want to achieve means DevOps is aiming to improve the speed and quality of the application by following this procedure, like taking the requirements in different sprints, by integrating the tools, deploying the application as soon as possible with high quality. So its main aim, DevOps main aim is to improve the speed and quality of the application by delivering it to the client. DevOps team use technology to automate manual processes. Here we are, as a DevOps engineer, you're not going to develop anything. You're not going to write C language, C++, C sharp, Java, Python. Like you're not going to develop any application. You're going to do automate the things. For that scripting, we use some scripting things. That scripting can be either shell scripting, or bash scripting or like YAML scripting or JSON scripting. You no need to learn again all the scriptings. If you are aware of at least one scripting, that is fine. In our course, I'll explain you like how to create YAML files in Ansible as well as in Terraform, uh, hash configuration language in AWS Cloud Formation also. I'll explain how to write YAML scripting. It is very, very easy. For sample YAML code, I'll show you. AWS Cloud Formation. This is a sample YAML scripting. It looks like just normal English only. Type AWS EC2 VPC properties, say dear block string, enable DNS hostname, boolean, enable DNS support boolean, instance string in like key value pair. It is just like key value. Key value means name, Aravind, rule number 12, like address, Hyderabad, uh, like rank, some number like this key value pair completely YAML will be. And you need to follow some alignment. Only the thing is alignment and key value pair. That's all. It's very, very simple and easy. See here, YAML code. Just so this is about DevOps. Now you tell me you got an idea what is DevOps? You understood?
Yeah, Arvind, I got the complete picture. I have a small note. Uh,
Yes.
yeah, is the deployment is the only difference between Agile and DevOps?
In DevOps, we get uh, see, multiple tools like here. In DevOps, we integrate tools. Like as I told you, in different stages, we use different tools to automate the processes for deploying the application. But in Agile methodology, we are not deploying the application as much as fast how we are doing in DevOps because of these integrating between the tools. There is no tools integration like how we do in DevOps. That's why we are delaying the delivery of application in agile and waterfall method. The deployment only, that is the main difference. Because delivering the application fast, that is main thing right here. DevOps aims to improve the speed and quality of
Yeah.
application delivery. Okay.
Okay. Does the DevOps engineers replace the test engineers?
No, no, there is no relation between DevOps and testing. That is
Yeah,
a
when you said that there will be no test engineers, apart from that, we will replace that role.
means
No?
that, that doesn't
Maybe we are performing testing there.
testing thing, that team doesn't comes under DevOps. That's altogether different team. Build team comes under DevOps. Deployment team
Yeah.
comes under DevOps team. But testing team is a different team. That is a separate team. Okay.
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 Hello,
Hmm.
I have one doubt. In DevOps, there are multiple tools, means Maven, GitHub. You are sharing all the knowledge of tools now here, which is required for DevOps.
Yes. I'll show you what all tools we are discussing. See, here is a course curriculum like we discuss about GitHub. That is for storing the source code. Then CI/CD tool Jenkins, containerization, deployment tool Docker, build tool Maven, orchestration tool, that is a deployment again Kubernetes, configuration management tool for automating the things Ansible, and for creating the infrastructure Terraform, for monitoring Prometheus and Grafana, scripting. Yeah, man. All these topics are covered.
Okay. Or after that means we are simultaneously perform testing on
For you,
simultaneously perform any application means in
I,
AWS there is a one platform Amazon.com से हमें वो करना पड़ता है ना.
in DevOps, I will show you by taking one sample application how we are going to integrate all these things. Like I have a ready code, I have a ready project. So in that project, what we do, we create a pipeline project, like we automate the things. I'll show you end to end. First, we'll discuss like different tools separately. And finally, in the final project, we integrate all the tools and we create one automation also.
Okay.
Okay. Okay, that. So from tomorrow onwards, we'll start Linux classes, regular classes. Till today, all these are free sessions. The meeting link also shared public. From tomorrow onwards, no free, no public, nothing. Whoever register for the course, whoever enroll for the course, they can only join the sessions. From tomorrow, I'll start Linux classes. All right.
Aravind, I have one doubt.
You can call,
Yeah,
you can call to me.
sorry.
You can ping to me. Okay.
Okay, sure.
Yes. Anything else? Okay then. Thank you. Bye.